All right, good afternoon, guys. So I'm going to explain your second part of your project. So the biggest thing here is now you're going to look at 3 different designs and determine which one's going to give you the maximum volume. So y'all are welcome to go and read the top part, but I'm going to go through the steps. First thing you're going to do is you're going to identify the polynomial equation that you're using to determine the volume of each box. Label the drawings to match your equations. So I'm going to use the length of 6 and the width of 5, and I'm just going to do design 1. I'm going to show you how you do design 1, and then you just repeat the steps for design 2 and 3. So the first thing you're going to do is you're going to redraw design 1. So as you can see, I went from here to here, and instead of using L and W, if you notice, I replaced them with my length and width, which are 6 and 5. So I replaced it. Now, after you replace it and you label your new diagram, you then had to come up with the equation. Now, the equation for volume is length times width times height, which if you notice, they've got length, width, and height, or whichever order. The order will not matter. So my equation will be x times 6 minus 2x over 2 times 5 minus 2x. Now I could reduce this. I could change it to 3 minus x, because 6 divided by 2 is 3, 2 divided by 2 is 1. Now some of your numbers you won't be able to divide, so you can leave it as a fraction. Doesn't matter, as long as you've got your 3 length, width, and height. Okay, so once you've got your equation, then you're going to have to sketch a graph. So I'm going to use Desmos.com, and let me write that down so you have that. So Desmos.com. Okay, it does work on the phones, at least on Android it does work. So I'm going to go to Desmos.com, and I'm going to start typing in my equation. So first it was x parentheses, and then the second parentheses I had 6 minus 2x. Come outside of the parentheses and put your division so it becomes a fraction. Oop, nope. Undo. I need a second parentheses. Okay. Divide by. So there we go. So I had to use a second parentheses to do the divide by. 2. All right, on the outside. And then I had 5 minus 2x. So 5 minus 2x. All right, and right away, so that's what it looked like. It was x times 6 minus 2x over 2 times 5 minus 2x. And here's my graph. So I'm going to re-sketch this. Now, if you want, you're welcome to take a screenshot of this, and I'm going to hide the keyboard. You're welcome to take a screenshot, print this for your reports, but I'm just going to sketch it. Okay, so I see it goes up and then back down. So I'm just going to sketch it over here. It goes up and then back down somewhere around, looks like 2.5. And I can hover and it does say 2.5. Now I also want to locate the maximum, which is right here. And if you click on it in Desmos, it tells you it. So my maximum is at 0.9, comma 6 point, that would round to about 6 point, I would just keep it at 6.05. So my maximum's up here. It's at 0.9, comma 6.05. Okay. So then you would do that same process for design 2 and 3. You'll re-sketch it, label your L and W's, replace them, simplify if you want, write the equation, which again, you just take the 3 things, put them in parentheses, graph it, find the maximum. At the end, that's pretty much step 2 and 3. At the end, step 4, you're going to write a short essay, like a paragraph, explaining this question: which box design is most efficient? So which one of these designs give you the most volume? Okay, all right, that's it.